Hello, everybody. Thank you for tuning in to the first episode of Cannabis WTF. It's our inaugural run. I couldn't be more excited to be doing this, but I couldn't be more excited to be doing it with two better people. Today, I've got Joe Edwards and Ben Ballinger with me. Joe's a colleague from YoFumo. Ben is with Diamond Miners Consulting. Today, we've been brought together here to discuss changing regulations around the cannabis space, specifically in Oregon, where they've started testing for aspergillus. So there's been enough kind of discussion around the internet, around us, to warrant having a conversation about aspergillus, why it's so dangerous, what we can do to prevent it, all the things that, frankly, these guys bring to the table with their years and years of experience. So when it comes to our agenda today, we kind of want to discuss, again, what aspergillus is, how it spreads, the fundamentals of the microbe itself. But then I'd really like to, exploit Ben's experience and talk about the operational side of things, what we can do to prevent it, get in there, really use Joe's experience to talk about remediation methodologies, and get deeper into the science side of things. It's one of my favorite things to do with it. But before we really get rolling on this, guys, I'd really like to have you introduce yourselves. Joe, since I know you better than I know Ben, I'm going to have you go first.
Absolutely, happy to, Harlan. I'm Joseph Edwards. I'm a biochemist and an engineer. I've been working in the cannabis industry since its onset in Colorado in 2009. And over the course of that time, I've participated in numerous projects from facility design, process renovation, facility remediation, SOP creation. Most recently, for the last 6 years, I've been with YoFumo Technologies as their chief science officer and vice president, really looking at developing technology specifically for the post-harvest space around microbial compliance and decontamination.
Ben, awesome to have you on board as well. We have not been working together nearly as long as I've been working with Joe, but if you wouldn't mind telling good people who you are, that'd be awesome.
Yeah, absolutely. I appreciate you guys having me on. My name is Benjamin Ballinger. I'm the managing director of Diamond Miners Consulting. We do consulting for cannabis operators, primarily in the realm of product development, operational excellence, business development, and leadership. Prior to sort of jumping into the consulting field, I was an operator myself for about 8 years, both in California and Michigan. In California, I was one of the co-founders of Shrine Group, managed operations across the supply chain for them. Obviously, they're one of the larger companies in the state at this point. More recently, I was the chief operating officer at Left Coast Holdings up in northern Michigan, which was an interesting sort of experience for me, and it's how I got introduced to you guys, because we had a large outdoor grow, where we were producing hundreds of thousands of pounds of biomass, for various outputs. And as people from Michigan know, Michigan's quite a moldy state. So it was interesting coming from sort of the California environment where, it's a little bit drier and the weather's obviously a lot better. And then moving into the Michigan environment and, needing to adjust sort of the way we were growing. And then also some of the, not just preventative measures, but also some maybe the remediation measures that were required to, have our product in a standard that we were comfortable with. So I'm very excited to be here and kind of want to talk about not just sort of the remediation itself, but also things we can do as cultivators from an operational perspective to make sure that we are limiting the, sort of the risk of having mold contamination in the first place, which I think is really sort of the goal that everyone has and that they should have to move forward.
Absolutely. Yeah, man, it's more of a holistic approach, and that's definitely the way that we want to address this as well. It's not just a remediation solution. It makes everyone's lives easier if we kind of bring it all the way around. Now, again, we're here because of Oregon, frankly. I would like to pretend like, we had a bigger plan than that, but Oregon has absolutely brought us to the table here. They changed the regulations in March to start testing for aspergillus, which again caught a lot of people off guard in their operations, maybe in their day-to-day lives. So, to start things from there, Joe, would you mind giving us a 10,000 foot on aspergillus, kind of, what it is, why it's dangerous, how it behaves, everything?
Happy to. From a 10,000 foot level, aspergillus is a pathogenic mold that has the propensity to cause a couple of really significant health effects. The primary one being aspergillosis, which is the propensity to cause a plethora of respiratory issues, especially in immunocompromised patients. And if we look at regulatory compliance as it applies to cannabis, it's one of the chief pathogens that we're really looking at testing now coast to coast. Oregon, of course, just bringing this on here in the last 30 days. And one of the things that is very difficult to understand with Aspergillus is its pervasiveness within a cultivation environment. Unfortunately, modern testing regulations as they apply to the cannabis industry simply show us a pass-fail. So without a quantification of how potentially pervasive the problem is within an environment, a lot of cultivators are scrambling not only to determine if they have a problem, but the scale and scope of that problem.
And why is, obviously, with this expansiveness and being tested for it, it poses a problem to growers. But why is there so much concern about Aspergillus on the consumer side?
Aspergillus is concerning to consumers not only because of the potential onset of aspergillosis, but as we look at cannabis both as an adult use compound and a medical compound, one of the things that we need to be guaranteeing is the health of our patients. Now, if that is from a pathogenic compound like Aspergillus, or if that's from a pesticide compound that's known to cause health concerns, all of these things need to be taken in consideration. And just like we test for heavy metals and just like we test for toxins, we need to be testing for pathogens that can potentially be harmful to these patients who across the medical sphere may be using them from an immunocompromised standpoint, or from an adult use sphere, maybe potentially consuming a product that is non-beneficial from a health perspective.
Now, Aspergillus is special, right? I hate to put it that simply, but we've you and I've had tons of conversations about different speciations and things like that. But how does Aspergillus typically kind of get into a grow? How does it spread? I know it's a more difficult question to answer because it's not just one way. But if you wouldn't mind giving us a quick overview on that.
There's a myriad of ways that Aspergillus can enter a cultivation environment. It can enter a cultivation environment naturally from the presence of decaying plant material found in drying rooms, cultivation environments, or really anywhere within the facility. When that decaying biomass is present, and when that decaying biomass is present with the proper environmental conditions, and when I say proper environmental conditions, I mean proper environmental conditions for its growth, which are often environments non-conducive for plant health, we can see explosive growth. And this often happens within the flowering phase and within the principal drying phase. We also get to contaminations, for example, like Aspergillus terreus, which are frequently found from soil-based contaminations. Oftentimes we find this in improperly prepared, improperly stored, or improperly treated cocoa material, frequently used as a grow medium within the cannabis industry. For example, one of the times that we've seen it predominantly is when cultivators may store pallets of cocoa outside. These pallets of cocoa are wrapped in plastic. They're continuously rained upon. They're drying. They're building up high humidities. And one of the things that we often forget, because we utilize cocoa as a soil medium, is that it's really an organic compound. And like any organic compound, it has the potential to build up a microbial load and bioburden. And then bringing that into the cultivation space, it can very rapidly spread. One of the things that we always have to be concerned about is the environmental conditions within a cultivation space, as improper temperature, improper humidity greatly spurn the spread of any organic or microbiological compound, Aspergillus not withholding.
Ben, I'm really happy to have you here because one of the most important considerations, obviously, is what kind of operational steps can be taken to proactively manage Aspergillus, any kind of microbial kind of concern from a grow standpoint?
Yeah, sure. And, I think that there's some stuff that can be done sort of in a general sense, regardless of what kind of grow environment you have. And then there's like certain things that are more specific to, indoor or greenhouse or an outdoor environment. So I'll start with some of the more general things and we can move into some of the more specific stuff after. Look, ultimately you've got a need to have airflow. You have a need to try to prevent in a situation where the mold is able to inhabit other plant structures that are near your cannabis. You want to try to maintain, humidity control as much as you can, which obviously in an outdoor environment is not something you can really do. But like, if we want to get specific with ventilation, I like to think of it as both interplant and intraplant airflow. So when I say interplant, I'm talking between the plants, right? So that can, be relevant in terms of how you lay your plants out, whether that's outdoors or indoors. Are you providing enough space in between the plants, not just for, obviously people to go in and work on the plants, but obviously so that the air can flow as well, so that there's not these huge, sort of congested spaces where there's a bunch of plant material and no air is getting through there, because that's the situation where you're going to have moisture that doesn't get removed from the plant, the moisture is going to be a breeding ground for the mold. When I say intra-plant, I'm talking within the plant itself. So things like defoliation, removing excess plant material, right? Opening those structures up, installing trellising so you can kind of guide the growth of the plant and keep it growing outwards and not growing in on itself. These are all things that you can do to, again, to increase the airflow. If it's an indoor greenhouse environment, installing, fans, circulating fans, so providing sort of that indirect airflow. I mean, there's actually even outdoor fans of these giant structures that you can put in place. I don't know how practical they are, and I've never used them, but the point is anything you can do to kind of keep the air moving in the plant is going to make a huge difference. Another thing is sort of doing both active and passive monitoring. So active monitoring is things like checking the plant every time you're working on it and looking for mold, right? If you see mold, bringing it up, and at that point you're able to hopefully put a sort of a correction in place prior to it becoming a bigger problem. Whether that's just cutting the piece off that's moldy in general, or taking a look at sort of your environmental controls and seeing if there's some sort of root cause that's going to become a bigger problem down the line. Something Joe brought up that's really pertinent and interesting is the input material for the grow medium, and you can test that for mold as well, and you should if you're going to be using it to grow your product, because again, if there's mold in your grow medium, that can transfer over to the plant. You can get actual specialized kits, sort of like at-home kits that you can use to test for mold yourself, so you don't have to rely on the lab coming out. That being said, some labs will provide sort of like field testing depending on sort of where they're at. We had a lab in Michigan that would come out and do field testing for us and help us sort of dial in our processes, which was really helpful. On a passive side, it's more about like sensors and sort of installing some sort of system that has fail-safes in place that can automatically adjust environmental controls if things sort of get out of line. So they've got, obviously humidity controls, temperature controls, airflow controls, but they even have like sensors that will mimic a leaf and can sort of analyze how much moisture is collecting on the leaf body itself, so that you can, it's basically the same type of structure in a functional sense, so that if it's collecting a lot of water, that the cannabis leaves are also collecting a lot of water, which again is going to be an issue. And then the final piece that I think it's not really a direct solution, but it's indirect, is making sure that your plants are healthy. So general plant care, because a healthy plant has a healthy immune system. And if it's got a healthy immune system, it's more likely able to fight off pathogens such as mold. So anything from proper IPM protocols, making sure that you're watering and providing the right nutrients at the right times, and just taking care of your plants is one of the best things you can do.
So you kind of mentioned it earlier in your answer, but if you wouldn't mind expanding, I know there's always a difference on how you treat things from an outdoor grow versus a greenhouse. Could you expand on that for me?
Yeah, sure. Let me start with kind of like the indoor and greenhouse, because obviously an indoor is sort of on one end of the spectrum in terms of the amount of environmental control you have, right? You have basically full environmental control. So theoretically speaking, if you're in an indoor environment, you should be able to prevent mold 100%. As you move towards greenhouse, it depends on the greenhouse. So some greenhouses are almost an indoor with a glass ceiling. Other greenhouses could be something like just a hoop house, right? And that's not going to have much environmental control at all. And then you've got outdoors, sort of the other end of the spectrum, which you're really at the mercy of nature and sort of the environment that you're in. Like I said before, growing in, let's say, Northern California, in Humboldt, for example, you've got like the ocean air and sort of a temperate climate. And, California in general is a lot more sunny and warm than Northern Michigan, where it's raining like half the time, even in the middle of summer, and winter starts, the frost ends in like May, and then the winter starts again in like September. So you have a lot more issues depending on where you're positioned with an outdoor grow. I think from an indoor perspective, and in greenhouse, the air quality. So things like treating air with UVC in the HVAC. So it's if any mold spores are circulating through, it's a closed air system, right? So as it's recirculating that air, it's sort of its own kill step in the HVAC itself. So it's not pushing back out contaminated air. HEPA filtration is also useful and should be used. Having good protocols for your people and your equipment. So making sure your people are always wearing PPE, that they have good sanitation practices when they go to the bathroom and they go eat. checking in and out, having sort of the facility layout in a way that they're coming in their outside clothes and they're changing into work safe clothes for the clean environment, and they're not cross contaminating that. The better you can do that, the better of an environment you're going to have in general. Same thing with equipment, right? So like the tools you use, the equipment you use both every day and periodically, making sure that those are cleaned effectively. And then, cleaning the rooms themselves, right? So after every grow, you should sort of have a standard protocol where you go in and you decontaminate the room, because then you're starting with that fresh slate, right? Because otherwise you can have sort of an aggregated issue that every run that you do, there's more and more sort of these microbes growing in random little crevices. Maybe it's not even on the surface, maybe it's somewhere in the ceiling or whatever. So being able to really dial that room in every time helps prevent it as well. There's a couple other things you can do. Positive air pressure, right? So having more air pressure within the room than outside the room helps prevent stuff from traveling into the room. If you're in a greenhouse specifically, having like a filtered air intake specifically, since that air is coming in from the outside, because that's an open loop system as opposed to an indoor grow where the air that you've got is, just being refiltered. And then when you're looking at more of an outdoor grow, you obviously have a lot less you can do. Like I said, there are still certain things that can be done. For example, at Left Coast, we experimented with a low-lying cover crop. So the first year that we ran harvest, we had a ton of weeds in between the rows, and it was grass like waist high, right? And the grass was growing a foot every single week. So we had pretty much constant mowing. And, it was a waste of time, but also the other problem was it was just circulating all of that dust, which inevitably was holding mold, because so moldy there back into the air all over the plants. So at the end of the season, we sat down and we said, hey, how do we save ourselves a lot of labor time by not having to mow repeatedly and weed whack and stuff, but also how do we prevent these plant structures that we don't want and that are harboring mold? And so what we did was we planted clover and a couple other plants. I can't remember exactly what they were. Our head of cultivation is expert on that. But regardless, we planted these low-lying cover crops that we didn't have to mow because they don't grow high, right? And they pushed out the other weeds. And so that way, because we didn't have to mow, we saved ourselves a time, and they weren't growing up into the cannabis. So there wasn't that sort of lack of airflow that I spoke about earlier as well. Another thing you can do, and this is something I worked with a different grow in Michigan on, is actually like a permeable netting, right? So instead of having to mess with cover crops, you actually install a netting that is, dense enough that plants can't get through it, but it still has space to allow drainage. So you're not ending up with pooling water on the top. And that way you don't have to do anything at all, and plants can't grow at all. And you just make sure that there's room for the cannabis plants, and everything else is covered with this stuff. So that's a huge one. There's a lot of proponents of living soil, no-till living soil. And sort of the concept is that when you don't till the soil, the microbiome, the organisms that live within the soil don't get pulled up to the surface and killed. And so they're able to actually provide a natural protection for plants, in addition to a lot of the inherent nutrients that the plants will need. So that's something that, people can explore. And then cultivar selection is a big one too, especially if you're in an environment like Michigan that has such a short summer and an early winter. You really want to make sure that you've got plants that are going to flower quickly enough and not run into sort of the end of October when things start getting really wet and problematic. So if you've got stuff that's finishing in September and you're able to harvest while it's still relatively dry, then you're avoiding a lot of these issues that happen later in the year. And you can also have cultivars that are more hardy and mold resistant in general, depending on sort of what their ancestors are. So picking, strains that'll work for that, or even having custom strains made specific for your environment. Maybe wrapping in some hemp genetics, given that they're typically more hardy than cannabis genetics, and other things like that. And then, like I said before, just cutting off mold if you find it. If you've got a branch on a plant and it's just lost, just get rid of it and don't let it just sit there and continue to spread that stuff any further.
I mean, it all kind of tracks, but you're right. Outdoor, you have so few variables that you can control. I think that very often we all get caught up in kind of the growing stages of cannabis. It's the prettiest part. It's what we talk about the most, but post-harvest is also hugely important. In your experience, I know that you've taken measures to deal with microbial issues there, but would you mind sharing some of those with us?
It's interesting because I think that a lot of growers, they kind of focus on the first part of the post harvest, right? Like the drying in particular gets a lot of attention because everyone knows that that's a sort of part of the process that's very susceptible to mold growth. But what I've seen a lot of is people sort of like give up after that, right? When it comes to long-term storage, a lot of times they'll, for instance, use turkey bags to store the product in, which are porous and can actually pull humidity in from the outside environment. So let's say you've got this product that's been perfectly dried and perfectly cured. It's at exactly the water activity level that you want. You put it in bags, you're storing it in your facility, waiting to use it for, processing or sell it to retailers or what have you. And then, unless your environment in your storage facility is exactly perfect, if it's a little bit too moist, then all of a sudden you're pulling that moisture in and all that stuff you did was for nothing. So sort of keeping track of the product all the way through the life cycle, I think, is really important, and making sure that you're using sort of like a storage mechanism that actually makes sense, whether that is super controlled environment or using something non-porous like a growth bag, so that the outside environment can't affect it. There's some other stuff you can do. For instance, the amount of time between when you cut the plant down and when you put it into the dry room and hang it up should be minimized as much as humanly possible, right? Because putting the plant on the ground, leaving it there in a pile, whatever, when it's already wet, that's not a sort of a great process. So having enough people there to help move those plants quickly, get them bucked, get all the excess plant material off of them that you don't care about drying. You don't want to be drying fan leaves and stuff like that. Get those off. Make sure it's just flour, and then get those into the drying room as quickly as you can. Also, indirect airflow, and I say indirect because if you point air directly at plants, A, it's not gentle enough, and B, it's not going to give as good of a sort of a homogeneous drying effect because it's going to dry more in certain areas than other areas. So you kind of want to point those fans off center and just have that air circulating around, and make sure that you haven't stacked the plants dense enough that, again, you can't get the airflow through. It's kind of the theme all throughout, right? Is having enough airflow because it's going to allow you to dry things quicker and keep the moisture at bay. Keeping temperatures between 60 and 70 is a big one. Most people know that. And humidity between like 45 and 55 max. Some growers like to sort of preload their humidity at, like, let's say 45 in the beginning to sort of kickstart the drying process, and then taper it up as they get towards the end to prevent it from getting over dry. Others just kind of set it at 55 and leave it. Either one can work, but you just want to make sure that you're not allowing it to be any more humid than that. And I think the best way to track humidity from a drying perspective is actually using a water activity monitor. It's an objective measurement. Old school ways, you would try to snap the stems and the twigs and whatnot, and it's just, you don't really know what that means, right? So you want to keep your water activity below 0.65 and above 0.55. Anything below that, you're over dry. So you monitor it as it's drying, go in there periodically, and when it hits in that range, then you pull it out. It's ready for curing. And then, depending on how you're curing, burping containers, assuming that you don't have like growth bags, making sure that you're getting that excess moisture out, so it's not just condensing again. And like I said before, properly storing for long term. Those are all, like, let's call them procedural things that you can do to make sure that you're putting yourself in the best possible position. Now, that being said, there's, we're talking about YoFumo here, so I think it's worth mentioning, ever since using your machines, I've sort of adopted a different stance on a kill step, which, sure, you control all the variables, you've got low microbial load, you test, it passes testing, that's great. There's still probably some colony there potentially, depending on the environment you're growing in. And anything that is there has the propensity to continue to propagate over time. So if you can run healthy material through a remediation machine, I don't even like the term remediation in this case, it's a preventative measure, right? And you don't have to run it for very long if you're using good material. I think that's where the sort of confusion lies, is people sort of think binary, right? They go, okay, well, if you're using remediation, it's because you have this, like, you didn't have good practices at all. You've got this disgusting moldy product and you're just trying to get it to pass, and you don't care if it's going to kill people when they smoke it, right?
Yeah.
But that's not the same as saying, hey, grow your product correctly, but also let's eliminate any possible organisms we can with a quick run through a kill step like a ozone remediator, so that when you put it into the packaging for long-term storage, there's no microorganisms at all, right? So then it's even less likely that over time mold can grow, because you can pass testing and then later there can be mold, right? So you're still not helping the customer just because it passed the testing. If they're smoking moldy product, then that's defeating the entire purpose for anyone that cares about the health of their customers. So
God forbid, let's take a scenario where, say you do fail for aspergillus or another yeast or mold. What kind of options do you usually see or pursue there? I mean, I know we discussed YoFumo, but I know we're not the only option. What have you worked with?
Yeah, from my perspective, I'm not affiliated with you guys, right? So I'm thinking from an operator's perspective. So I would say, like, I wouldn't use remediation on product that's like too moldy. I just care too much about the quality of the product. Like I said before, like, it's not serving anybody. So in that case, I think it depends on how much is present, right? So if it's a small amount of it barely didn't pass and you can run it through the machine for like 6 to 8 hours, by all means. Now, again, if you did it the way I said it and you did that as a preventative measure, you're not going to have the problem in the first place, right? Unless, again, you have very moldy product, in which case it shouldn't be being run. But if you have product that, for whatever reason, your processes broke down or whatever, and it's just got tons of CFUs, you're better off sending it to extraction, because like no one wants to smoke product that was moldy. You're gonna have to run it so long in the machine, it's just not gonna be something that anybody wants to consume at that point. So, you can extract it either as sort of like cured resin, depending on, again, how moldy it is. People don't really want to smoke moldy cured resin either. Or you can run it to distillate. Regardless, if you use a solvent extraction method, it's going to kill the microbes and filter them out. But it could affect the flavor, right? Which is why a cured resin might not be a good option. With distillate, you're distilling it down to just the THC anyway, and there's no flavor involved. So you can kind of use almost anything for that, which is one of the reasons why it always gets a bad rap. But yeah, so those are kind of your two options. Obviously, that's not an ideal option, because if you're selling it for biomass for extraction, you're going to be selling it for a lot less than you probably were planning on selling it for as flower. In many cases, perhaps less than it costs you to grow it. So best path forward always is to have good practices in place in the beginning, from the get-go, and grow good product, and not try to panic at the end of it and try to figure out what you're going to do to save your crappy product.
Absolutely. Yep, that's an interesting theme in all these answers. Joe, YoFumo is not the only decontamination methodology. And if people do, or remediation methodology, if people decide to go down that route, would you mind kind of running us through some of the other options? I mean, they've all got pros and cons, and I don't know if there's anybody better in the world to answer that question than you.
They do indeed. And kind of echoing again what Ben said, this really does begin at facility and process design, and it continues down with operational implementation. And where it ends is potentially within reduction of bioburden. And this is really where I can't stress enough that decontamination or remediation devices, be they YoFumos or others, really have that place. We're not proposing for the decontamination of heavily bioburden material. And this kind of goes back to our earlier comment on aspergillus, that we don't have a quantitative measurement of exactly the pervasiveness of the contamination, which makes aspergillus a very interesting microbe to look at from a decontamination and preventative standpoint, is because we very often do not know the size of the mountain we're scaling, or the size of the dog in the fight, so to speak. With that in mind, there's many ways that we can utilize, as Ben said, decontamination systems as best practice, as bioburden reducers, in order to achieve a standard. And that standard we're looking to achieve isn't necessarily a passing test for regulatory compliance, but it's a passing examination of microbial susceptibility and microbial load of the plant. Oftentimes, we look at the principal drying phase as the largest, most rampant potential growth of microbial populations. I often like to put it in a parasitic host analogy, the plant being the host, the microbe being the parasite. It's very rare that we see large-scale contaminations of living plants. As has been mentioned, living plants are currently producing cellular structures. They're currently repairing. They're fighting off infections actively. But however, once we stop that cultivation process, even though we still have water content, we still have cellular structure, we still have chemical reactions happening, the efficacy of those reactions drops exponentially on a day-to-day, hour-by-hour, minute-by-minute basis. So how can we guarantee the validity of a product? Well, we can guarantee the validity of a product by reducing or standardizing that bioburden, not from some extraordinarily number to pass a testing where this product should never have been sold anyway, but to prevent touch or contact transfer, to prevent that small bioburden buildup as we approach and pursue that active water content of 0.65 to 0.55. As that water content declinates to those stable levels, we do still have the propensity for microbial growth and expansion. And that's something that we want to limit, especially knowing that that is not the last phase of life for this flower. It's still likely going to go through a trim phase. It's going to go through a cure phase. It's going to go through a packaging phase. During all of these phases, we have human interactions. Humans are frequently the dirtiest thing in a cultivation environment and something we need to be keenly aware for. Just like we utilize PPE to prevent and protect, this is how decontamination systems should be used. Be it ozone, be it chlorine dioxide, be it radio frequency, be it IR, be it X-ray radiation. And all of these have their benefits. All of these have their drawbacks. Ozone is very cheap, easy to use. The systems are easy to maintain and implement. Radiation, for example, can decontaminate through an existing package. So if you're working in a regulatory environment where all of your product is prepackaged, by the time you send out your compliance testing, you may not have the ability or labor contingent to remove hundreds and potentially thousands of prepackaged jars, be they eighths, grams, or other, and actually go through that remediation process. So in that situation, radiation may be the best for you. Again, attacking the problem upstream is almost always better than attacking it downstream. Limiting the ability for micropopulation to expand is always to the benefit of the cultivator and in the end to the benefit of the consumer. There are technologies such as IR that are frankly great for sanitization. We mentioned soil a couple of times in this call. One of the easy ways to decontaminate soil mediums is through IR exposure, because we're not worried about decarboxylation of cannabinoids, because we're not worried about any damage to volatile organic compounds. Using something like IR and heat-based systems are a very easy way to decontaminate a large spectrum of microbes. Similarly, chlorine dioxide, originally a technology developed for the greater food and ag industries, and it's absolutely wonderful to a degree for hard rind, soft rind, shelled and seeded biomasses, because those biomasses have the ability to be rinsed afterwards. One of the iniquities of that particular chemistry is that it's volumetric in nature, and if used improperly, it can have a remained in residue. For example, if you have a chemistry that is designed to be active on 25,000 cubic feet of space, and you only have 17,000 cubic feet of space, for example, you're going to have a remaining compound. Now, one of the things that some of these technologies can be utilized is cross-platform. While chlorine dioxide may not be the best for a leafy biomass from a decontamination standpoint, because its pervasive nature, it is wonderful at sanitizing dry rooms. It's wonderful at continual facility health and maintenance. It's also great for older facilities that may have not have had the benefit of UV elements within the HVAC or proper HEPA filtration. You can use it as a preventative measure of cleaning vents. Ozone, again, is one of the cheaper, more prevalent ways. Aqueous ozone is a wonderful thing to use for decontamination, along with peracetic acid and many other decontamination compounds. However, when it comes to plant-based decontamination, again, one of the things that I cannot stress enough is regardless if it's ozone, if it's IR, if it's RF, if it's radiation, we're looking at standardization of bioburden, reduction of bioburden, not necessarily the reclamation of pathogenic or biocompromised product that, regardless of its level of sanitization or decontamination, isn't fit for human consumption.
I couldn't agree more. I guess that what this does is it brings us to my favorite part of the program. I'm sure it will be. This is the first episode, but it's got to be. This is our kind of Q&A section. Basically what I've done, because this is our first episode, I've gone and hoovered up all my favorite questions from clients and, colleagues, people on the internet, which is always a great source. And basically my objective here is to bring them to you guys and see if I can stump y'all. So first up is one that we get constantly, especially here at YoFumo. And when it comes to decontaminating with ozone, the question is, doesn't ozone destroy terpenes and turn flower brown? Joe, that was you.
I'll go ahead and dive right into this. Can ozone destroy terpenes? Can ozone turn flower brown? Yes, it can. Ozone is an oxidizing agent. Any oxidizing agent will have that potential and that propensity. It becomes a question of saturation and exposure time. Again, this goes back to reclamation of heavily bioburdened product being a non-ideal practice. Under proper circumstances, under proper operating conditions, as Ben has described, where you have best practices in place, where you only need to do a cursory decontamination to limit the bioburden or limit a touch transfer or touch contact potential, no, there's very little propensity for destruction of terpene compounds or oxidization of flower pigment. Now, if we stretch the timeline out to the other side and we say we're decontaminating with ozone, IR, radiation for, we'll call it periods in excess of 24 hours, that propensity starts to rise. The longer we expose, the greater chance that we'll have oxidation reactions, and the greater those reactions will be, bar none.
And Ben, I know that you have wrangled some ozone in your time. What was your experience regarding the brownness of flower and terpene destruction?
Yeah, it's interesting you mentioned that because, I was a little skeptical in the beginning because it seems like every single remediation tech claims that the other techs, are going to destroy the flower, right? So, originally we were kind of looking at rad, but I'm not a huge fan of radiation in general, which may or may not be logical, but it's just kind of like my natural tendency. So when we were looking at ozone, I was like, all right, well, we're gonna get a machine, but we're gonna try it like sort of a pilot run first, right? Because what I don't want to do is I don't want to run all of our product through here and then put it on the market and then have it be crap. So we did a split smoke test and we did a analytical test, and this was one of the operations I was advising in Michigan. So we basically took some products, same strain, right? We took some product, we ran it through treatment for about 6 hours, and we sent sample of that to the testing lab. We took untreated product of the same cultivar, same batch, everything, sent that directly to the lab so we could test the terpene analysis, right? Obviously we tested microbes too, came out clean, but from a terpene perspective, we didn't see any significant reduction in terpenes from running it at that amount of time. And the reason I chose that amount of time was because we had talked to Joe about the typical CFUs we were seeing, and he had mentioned, based on his experience, like kind of what runtime we would need as a minimum to get it down to, a level that was going to pass testing, right? Because ultimately you don't want to, if you can get it clean in 6 hours, you don't want to run it for 18 hours because then at that point there's no extra benefits. You're just destroying the flower.
Yeah.
So again, we ran it for 6 hours, sent it to the lab, didn't see any issues with the terpenes. And then we also did a blind smoke test to get some sort of subjective type of measurement. And again, people could not tell the difference. I've heard of there being an off taste and stuff like that. I didn't experience that, neither did any of the people that we had test the product. I think, I'm just guessing here, but I'm thinking maybe that's also a byproduct of running it for a really long time. Maybe you guys can sort of clarify that. But yeah, so it's been great for us. It's why one of the reasons why I'm sort of a proponent of the technology, again, in conjunction, and it needs to be stressed, in conjunction with proper growing practices, right? But if you do that, you should be able to get the product treated without seeing any sort of substantial differences.
Growing practices in conjunction are absolutely pivotal. I think that, and this is just kind of an aside, I guess, but oftentimes remediation technologies are looked at as being kind of a band-aid for everything. And, while they can be, we've knocked down CFU counts that are through the roof, they absolutely shouldn't be. And, I'm glad that we keep hitting on that because, it makes everything better if you're starting with a smaller problem. Our next
just to jump in, one other thing, yep. Sorry, I was just gonna say,
go for it.
Another thing that I really liked about your company was when we were initially talking about implementing the system. I had a conversation with Joe, and I was interested because he was talking about all these things I'm talking about and not really focusing on the machine, right? Not just coming in and saying, "Oh, just use this machine, doesn't matter," right? And I've been in the industry long enough. I've had experiences with mostly in the realm of extraction, but I've had experiences with machine companies that don't care and they're just trying to sell you equipment, right? And so it was nice, and it sort of built trust for me to be able to have someone talk to me about preventative measures, which technically reduces your need for remediation, right? But ultimately, it showed me that you guys actually care about people growing good product, and I think we need more of that in this industry, and less of the bad actors that are just trying to sort of push through things that aren't really helping anybody out.
And Ben, couldn't agree more. And one of the things that we've always been clamoring for on this end is not only from the realm of best practice, but also from data acquisition, is encouraging cultivators to utilize things like swab-based analysis of the facilities to monitor the health, to track a potential contamination, to track the level of bioburden or background microbial load, and to pursue eradication, not remediation. And part and parcel to that, not necessarily from use of the machines, but how can we go in, how can we look at potentially R&D testing a product, understanding the variance of cultivar susceptibility, understanding how we maybe need to treat crop A different from crop B, even within rooms of a facility. They may be built to mirror, but as we all well know, I think that they're not quite mirrors of each other. They're closer to siblings than they are twins. And with that becomes a whole propensity of uniquities that each room has, each cultivation environment may express, and being prepared to deal with those, not necessarily from a blanket perspective of, okay, this is a process we run everything through, but from a tactical perspective of, this is what's necessary to standardize our product.
Joe, our next question is, are there any dangers to ozone which would pertain to residue or harmful chemicals left on the flower?
So left in the flower, no, but let's make it very clear that
I guess, yeah.
ozone is a chemical, and it's a poisonous chemical gas in the form that we're talking about it right now. There's a reason that OSHA has safety limits for ozone, be it for exposure and be it for the time of exposure. The state of Colorado, happy to call home, we have frequent ozone warnings where we actually advise the populace to limit their time outdoors, to carpool. Ozone can be very harmful in the wrong circumstance, or essentially incredibly harmful if high levels of exposure are presented to any person, especially potentially an immunocompromised person or a person with asthma or any of the variants thereof. It can be extremely detrimental. This is part of the reason that ozone technologies often utilize hermetically sealed cabinets. One of the benefits of ozone to this degree is its instability. An ozone molecule, once created at this particular barometric pressure, lasts approximately 20 minutes and it decays in about a 2-to-1 ratio to generation, which allows ozone to be used for biomass decontamination, because after, frankly, a very short period of time, we can safely say that the ozone content has mitigated, dispersed, and diffused back into atmospheric oxygen and free oxygen. And that's kind of really one of its main benefits around that and around its ease of access. But at the end of the day, it needs to be understood that ozone is a chemical, and it is potentially a harmful chemical if used improperly.
So fundamentally, use it properly, and you're good. And that dispersion is another way that you don't have that residue, right?
Absolutely. Well, there's no residue that's going to be left over on a plant from ozone. What you can have is a buildup of ozone within a biomass. However, that buildup is still something that can be very quickly dispersed simply through gaseous exchange, burping practices, or just with time. Again, this is getting into those high concentration, long decontamination scenarios, which I don't think anybody here is a proponent of. But yes, absolutely. And let's say we expose product to ozone saturation for an inordinate period of time, 72 hours plus. It will take time for that ozone content to disperse.
And we've seen that. We've seen some things together, Joe. It's fun out there.
We have after many years in the industry. I've seen as many things that make me smile as make me cringe, and Ben, I'm sure that's true for you as well.
I think there have been some things that have made us run. And this is the question I've really been waiting to ask. We had someone they contacted us on LinkedIn, and there are scientists that posed a question that I think is best addressed by our own scientists. They said, and I'm going to read this word for word: ozone can kill microbes, but no decon method completely destroys microbes or makes them, quote, disappear. I would ask the people who make those claims for their scientific evidence that ozone destroys mycotoxins, allergens, or cell structure components like LPS. See if they stick with their claims then. And then she went on and expanded on that and said, if these companies are claiming that ozone completely destroys microbes, including their toxins, allergens, and other aminoactive components, how can they also claim that terpenes and cannabinoids remain untouched? Anyone with a basic chemistry understanding can tell you that ozone is an oxidizer and does not discriminate. It can act on both plant and microbe.
So we've touched on a couple elements of this question already with the previous two. One, let me start off with saying there is no known study that shows ozone or other decontamination, be IR, RF, being effective in the realms of cannabis for microtoxins or aflatoxins. Not that they may not be, but there is currently not data out there to support any of those claims. So that's absolutely correct. In the realm of disappear, there is no decontamination technology that's a magic eraser. Nothing is coming in and removing something. There's always going to be remainder, be that leaving a cultural but non-viable cell, being that leaving leftover an inert carbon. There's always something remainded. And this is where, again, we need to really begin looking at heavily bioburdened or pathogenic burdened product and what the risk thereof may be. One of the things with culturable but non-viable bacteria is that there are studies that show that there are some bacteria that has the propensity to become viable again. We're currently looking at studies that show what the timelines of this may be, but this is something that very much needs to be considered when utilizing any decontamination technology, that if you're looking at a pathogen, if there is the presence of it, is the presence of that pathogen burdensome to a degree where any type of remediation or decontamination technology is applicable? That's something that we're going to have to look at as an industry as a whole from a standards perspective of saying, okay, where is the line of recoverability? Where is the line of acceptance? And that's something that frankly needs to happen on a regulatory level and really needs to be a standardization that is adopted as the industry as a whole. Understanding that we came from a medical-based industry, and if we're looking at this from an API, an active pharmaceutical ingredient perspective, it's completely unacceptable to have any potential occurrence or propensity for it. Even within the adult use market, I don't think that treating something from a medical perspective or a recreational perspective with variants makes sense either. Patient safety and consumer safety always needs to be a paramount concern. That's why we have microbial regulations. That's why we have compliance standards. And that's why we need to see a refinement and more general acceptance of those on a federal level. And this is something that the industry is working to, albeit slowly. I think that answered your question. The other part of it, aflatoxins, microtoxins, allergens. This is why we have different delineations on testing. It's not guaranteed that a pathogenic microbe will begin to produce those aflatoxins or microtoxins or allergens. Again, this comes down to maintenance of environment. If we're exposing bioburdened biomass that has a pathogen that could lead to a toxin to a conducive environment for its growth and development, it will happen. This is why proper storage, proper handling, even after harvest, even through packaging and retail distribution is paramount.
And we test for those toxins as well, which I think is always really good. It's not uniform, but
we do. And part of testing for those toxins separately from the biological compounds that produce them is kind of a good first step in understanding how this problem is far more pervasive than the industry currently views it, and how very quickly it can become burdensome not only to a cultivator, to a consumer, where you may have what was initially a healthy plant through cultivation, but an imbalance in a principal drying room has now led to a contamination. That contamination has now, through improper handling and storage practices, spread to a toxin developing pathogen. And this is something that we need to be acutely aware of, that the burden on the producer, the burden on the cultivator doesn't simply stop when the plant is cut down.
Yeah, absolutely. Well, thank you guys thank both of you for your time. It's really awesome to have you on here. I, really enjoyed it myself, which is the most important part of these things. But, bringing your expertise to the questions that, people are posing to us and hopefully delivering actual information for people that are our listeners is, ultimately our goal. So, Ben, thank you for coming on. I know that your time setting up Diamond Miners Consulting has been really busy. So, carving out time is hard for you. But I absolutely implore our listeners to go and visit your website, diamondminers.co. Check out the virtual library of resources that you've set up there. And even if they're so inclined, take your 7-day course, which, mind you, is free. So, again, thanks for coming. couldn't ask for someone better to start this thing off with. Joe, I get to spend a lot more time with you than I do with Ben. But I still appreciate your coming too. You might not have been quite as optional as he was, but our time spent together at YoFumo, decontaminating all sorts of fun stuff and dealing with a variety of clients in a variety of places. I think at this point we're at 4 continents. It's been an absolute blast. So thank you for your time.
Well, it's been a wild ride, and thank you for kind of creating this platform. And as you have heard me say numerous times over the years, I've stood on a soapbox and kind of screamed my lungs ragged to foster a more academic environment, a more honest conversation through cultivators, producers, manufacturers, extractors, retailers, every aspect of this industry. As we approach a CGAP or GMP style of production, one of the things that we need to do is work collaboratively with each other. The idea that everybody's methodology is proprietary, the idea that you've configured a system in some unique way that no one has, is frankly an idea that needs to go the way of the dinosaur. The more we are open about this, the more communicative we are about this, not only from bioburden, not only from remediation, but cultivation practices, nutrient delivery practices, fertigation, equipment recommendations. The more that we can do to help the industry, the better our industry will be as a whole. And fostering these academic conversations is frankly the first step in my mind, and I couldn't be happier to be a part of it. So Harlan, again, thank you for having both of us.
Absolutely. And Ben, I know that actually we had that conversation when we first met. So thank you for practicing what you preach, man. I appreciate it.
I appreciate you guys too.
All right, guys.
All right,
We'll take care. Oh, and actually, before we leave, one last thing that I make a habit of trying to forget. Any of our listeners that are so inclined, I would love it if you guys would send in questions. If you haven't noticed, it is my goal to stump Joe and whoever else is on here with us. So toss us whatever you got, and hopefully I can get them next time. Thank you all. Bye.
Bye, everybody.